Hello everyone, this is a video lecture for Calculus 1 section 5.2, Definite Integrals, where we will not be doing definite integrals. That's right, the title is very deceiving, and I'm sorry for that. Welcome back to Math Prison, and your stay will be another couple of sections. So, the reason why I've been saying this in particular is because they just won't let us do the real math. They want us to do other things. And you know what? I don't like it. I don't know if you like it or not, but we're going to have to get through it. And so I'm going to put on a happy face, and we're just going to buckle down and do it. And now I will say that there are times I will cheat the system because I just don't care anymore, and I will just do the real math like normal. I'm not actually, when I say cheat the system, I'm not like doing something wrong. I'm actually finally doing it right. And when we get to that point, I will warn you. And in fact, the very first question is where I'm going to circumvent their thoughts, and I'm going to do it my way, which is, well, it's the way you're going to do it forevermore after this. So we're going to do a real integral here. Okay, they have this cool big formula here because they're so cool, and they're wanting to say, hey, we're going to go from 2 to blank of blank dx is equal to blank. And so they're wanting to set up a definite integral. I mean, this part's legitimate, I guess, if you want to look at the patterns. That horrible P word. But if you're looking here, 2 to 4, that's easy. I got 3x cubed minus 7x. Just get rid of the x sub I part. And then we have to do our definite integral. I am not sure how they wanted you to go about doing this. There's probably some long limit way to do it. I don't want to do that because that's not what we're going to do. We're going to actually take an integral. We're going to really do it. So, as I've been saying for quite a while now, you're going to add 1 to the power, and then you're going to divide by that new power. And this applies to each individual term. And so let's look at the 3x cubed for a second. So I'm going to integrate this. The 3 stays on the outside. And then I say, oh, well, now that's going to be a 4 power, right? See this 3? It goes into a 4. This 3 and that 3, they just stay the same. That's whatever. But that 3 turns into a 4, and then you divide by the new power. And so I guess you could write it as like 3/4 x to the 4th. That's fine too. And that's just that one term. So now let's look at the 7x term. And in fact, it's negative 7x. Let's just go that route. For sure, you'll retain the negative 7 in the front. I mean, that's the easy part. And so what's the power here is a 1. And so I'm going to change that 1 into a 2. And then I'm going to divide by that 2. Okay? And so that's my term there. And so in a way, I guess I could rewrite this as now 3/4 x to the 4th minus 7/2 x squared. And I'm going to go when or from 2 to 4. That's the when bar, or such that. I guess you could say that's a such that bar. Such that you're going from 2 to 4. Okay. And so this is where you're going to apply the fundamental theorem of calculus, which apparently is actually the next section where, again, you're not actually doing the fundamental theorem of calculus, sadly. But it's okay. We'll get out of this eventually. What you're going to do is you're going to take the 4 and you're going to multiply it. You're going to actually plug it in to both of those terms. You're just going to plug it in. Just like that. And then you subtract whenever you plug in the bottom term. So you plug in the 2, same thing. And then you're going to subtract those. Now that looks like a lot, but honestly, it's not. I just skipped to the end actually and went to the calculator. It's 132. And that's how you do one of those problems. So, let's keep going. Next problem, 52036. And so they got this crazy graph thing, which you know is always going to be better on WebAssign rather than with me drawing it, but I'll try my hardest. That's an 18, and that's going to be a 21. This is a 12. -6. Apparently this right here is a 3, not to scale. Okay, well, there you go. And so what they're saying is that we have the area here, we got an area right here, we got the area right here, and they're wanting to answer a lot of separate little answers. So, integral from 0 to 6 of g of x dx. Okay, so 0 to 6 is going to be this little interval here. They're looking for, guess what? The area of a triangle. Oh my goodness. 1/2 base times height. 1/2. My base is a 6. My height is a 12. It's 36. Wow. Congratulations. Now they're wanting to go from 6 to 18. Ooh, can we do it? Can we do it? 6 to 18, that's this interval. It looks like a half circle. So half of the pi r squared. What's my radius here? It's 6. Half pi 6 squared. That's 18 pi. It's -18 pi. Oh, because it's, of course, below the x-axis here. So there, I know it's not technically an area, kind of, but anything below there is going to be a negative value. If we were to do actual integrals earlier, I could have shown you that. But we're doing it their way because I just need you to pass this class. So 0 to 21. Well, that's like all of this stuff. So we got our previous here. We got this thing here. And then we got another triangle. Again, that's half of base times height. So guess what? We got the 36 minus the 18 pi. And we're going to add another 1/2 base times height. The base here is going to be a 3. And the height here is going to be a 3. 3, 3. Calculator, 81 over 2 minus 18 pi. That's right! I basically just put those together and called it a day. And there's a lot more to this than just this one, but I'm sure you could do that because it's just so much fun. 0, 5, 5. Here we go. I got integral 1 to 3 of e to the x dx is equal to e to the 3 minus e. Using this, we need to find integral of 1 to 3 of 3e to the x plus 6d. Oh, this is my favorite problem ever. Care about that. I'm just going to do it the real way. So, as a formula, I'm going to give you a formula here. This is a pretty nifty little formula. If you ever say the integral of e to the x dx, you're going to get e to the x plus c. In a way here, it's kind of interesting because normally when we say like integral of x squared, I add 1 to the power and divide by the new power, right? So that's normal. And this is good. But in this case, I'm going from an e to the x to a, well, e to the x. It does not change. It does not change. And again, as a reminder, this big old summation and the dx both go away, you know, leaving behind this thing. I mean, that's for any integral, honestly. But it's kind of weird to see that e to the x goes to e to the x. It's just one of those formulas. So, let's really do some real math. First off, I want to split this. I'm going to take the 3 and move it to the front. And I want to split that e up. How do I do that? This is those exponential rules. I got e to the x times e to the 6. Okay. Now pause for a second here. Okay, so what's going on is that if you're multiplying your bases, you're adding your powers. I just went backwards. This is a constant, and it can come to the front with the 3. Okay, now I can actually do some math here. Oops. And so this right here, e to the x, turns into e to the x. But we're going from 1 to 3. So I plug in the 3, and then I plug in the 1, and you subtract them. So I'm plugging in the 3, then subtract, and then I plug in the 1. You can keep this in the front. Doesn't really ever change. And so we got e cubed minus e, I guess. And that's what they were saying up here, if you noticed. See, they did that. There is no need to go further, but if you really, really, really want to, you could go ahead and distribute. That's 3e to the 9 minus e to the 7. Just another way to do it. And back we go to Math Prison. So 52057. I got integral -4 to 2 f of x dx plus integral of 2 to 3 of f of x dx minus integral of -4 to -3 f of x dx is equal to integral of something to something f of x dx. Oh my. So let's say we start here at -4 and I go all the way to +2. See, so that's done. And then I go from 2 to 3. Okay, so now we're here at 3, so that one's done. But now I need to subtract, I need to remove this -4, -3. Oh, that is very weird. Okay, so I have all of this here, and I want to remove -4 to -3. Well, -3 is like right there, so I'm going to remove this from my answer. And so then what am I left with? Well, it seems like I actually will eventually start at -3, and I go all the way to +3. And yep, that's the answer. Ta-da! We did it. So fun. That's exactly what he wanted to do on a Sunday night before the due date. 52009. We got integral 0 to 8 of sine of sine of the square root of x dx. And they say n equals 4. And they say use the midpoint rule. Ah, that's my favorite friend ever. Now, just pause for a second here. Normally, I like to cheat the system, and I want to say, oh, well, right here, we could do sine integral blah, blah, blah. And there is a way to do integral sine, but there's not a way to do integral of sine of the square root of x, as far as I know. That would definitely take a lot more time. There's probably a way to make it work. I just don't know it. And so what I would rather say for you to do is just follow directions. And so midpoint rule it is. How we do that? Well, we've got 0 to 8, cut it up into 4 rectangles. And you can guess how this is going to go. 0 to 8. Something kind of like that. Sounds awesome. 4, 2, and 6. And so the midpoints would be here at 1, 3, 5, and 7. And so then whatever this graph's going to do, you go up and you make a rectangle based on when the midpoint is touching that graph. I don't know if that's it. I just made something up. And so let's go ahead and do this. This is how you're going to make it work. And we just did this in the... So sine of the square root of 1 plus sine of the square root of 3, sine of the square root of 5, plus sine and the square root of 7, and then all of this stuff times the width is 2. Now, please make sure that you're in radian mode when you put this in your calculator, because the answer is 6.182037. There you go. Man, there's so much learning going on. And so we got -3 to 8 of absolute value of 1/2 x dx. And they say, what's this answer equal to? This one is a peculiar one. Again, I'd rather see all of these peculiar answers later. I want to do the normal day-to-day math that we should be doing, and then we can come up to the situations. On the last, in the last video, I had made an analogy about like learning about how a car works versus driving a car, and how I suppose that we should be learning how the gas and the brake and the steering wheel works way before we ever have to learn about the combustion engines and the, I don't know, the suspension systems and just, I don't know, all kind of different things. Well, here's a special situation. You've been driving here for a couple months now, and you notice that it's raining. And so what do? When it's raining? Well, you got all those little clicker flippers on the side of the steering wheel. You start flipping things, and eventually you get your windshield wipers to go back and forth. And so that's one of these little situations that doesn't really affect the rest of what we're doing. But once in a while we have to learn something new, and that's okay. So I'm just going to make up a graph, and we're going from -3 all the way to 8. And this graph here is supposed to be this 1/2 x business, okay? Now, it's the absolute value, so that's why it's positive. It's like that V-shaped stuff, but it's half, so it's kind of more flattened. And I know it's not the scale, but there you go. Well, notice that we have a triangle, and we have another triangle. And so they say, hey, go ahead and add them up. So, yep, that's all we're doing. 1/2 base times height plus 1/2 base times height. Now, what's the height right here? It's easy, because what you're going to do is plug that number in, and you get 3/2. And so we got 1/2 base of 3. That's a 3 distance right here. And then we get a 3/2 height. And then we got our 8 base, and then our height here, again, is half as much. Is going to be a 4. And so you put all the stuff in the calculator, and 73/4 is your answer. Just looking to see if I skipped something or not. So, keep moving. 52022. I've got the limit as n goes to infinity of the summation of I equals 1 to n of x sub I divided by x sub I squared plus 2. A little bit of song in there. Oh, delta x. Gotta have the delta x. Otherwise, oh man, totally wrong. And we're going from 1 to 8. And they want to fill in that integral again. I am so happy for them. This is such learning. And so I feel like I'm being way too sarcastic, and I probably am. But you know what? It's okay. We're going to get through this together. It's a survival technique. If I wasn't sarcastic, this would be a very boring lecture indeed. That was all they wanted. Now, can you integrate that? Yes, you can. I would just say not right now, please. That's one of the more advanced cases, okay? Now, that's more of a day-to-day kind of integral. It's a very good integral to go and try, but it is a little bit more advanced than what we should be doing right now, okay? So it's like, you know, you drive on the interstate every day to get to work, but then all of a sudden they're saying, hey, can you go ahead and get in a NASCAR race? And it's similar. It's similar. I would say that this is a bit more advanced, okay? Next one, we got delta x is equal to b minus a over n. Very good. I got x sub I is equal to a plus I times delta x. Very good. I got a to b of f of x dx is equal, okay, is equal to the limit as n goes to infinity, I go from 1 to n of f of xi delta x. I'm so happy they've wasted our time. We're supposed to integrate from 1 to 4 of x squared minus 4x plus 8 dx. Go. Okay, guys, I'll give you a minute to go ahead and think about how you're going to approach this problem. Da, 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 da. No, I can't do it. I can't wait. So, yeah, I'm going to do it. It even says here in the notes here, I'm doing it differently than what they want. I don't know what they're going with here, and that is a great job for them. I mean, yes. Let's just pause for a second. Couldn't I, as your math teacher, explain what all this means? And I kind of did already in the last section, but, you know, let's just recap real quick. This is a big summation. Oop, I already zoomed out. Sorry. Let me zoom back out here. Okay. This is a big integral summation. So you got sigma or s. This is Greek. That's Latin. It's got a big old integral of f of x dx delta d. D and delta are the same thing, just like sigma and s. I kind of mixed up my Latin though. There you go. Okay, there you go. So Greek, Latin, same thing. Woohoo! All right. So you can see that this is equal to that. That's cool. This whole limit thing we already explained. We had a graph, let's say, and I used to use all these rectangles to make it work. And then I got a lot more rectangles. And then I got basically so many rectangles, they just basically became a lot of vertical lines. I could fill it all in and I can get the exact answer and everyone's so happy. Whew. Yeah, let's just integrate. So what we're going to do is add 1 to the power and divide by the new power. So x squared now becomes x cubed over 3. Wow. We got a negative 4x. Well, remember, that's a 1 power, so I'm going to add 1 to the power and divide by the new power. So cool. What's your power of x here? This is a power of 0. And so then now we're going to have a power of 1 over 1. And then we would say plus c, but here they have a definite integral, so we're going to go 1 to 4. And so just like every other time, I'm going to plug in the 4, and then subtract, and then plug in the 1. And so plugging in the 4, we get 4 cubed over 3 minus, these guys actually turn into a 2, doesn't it? And then we got 4 squared, and then plus 8 times the 4. Okay. So all of that minus, and then I'm going to plug in the 1. So now I got 1 cubed over 3 minus 2 times 1 squared plus 8 times 1. And you do all that in your scientific calculator, and you get 15. Wow. 52026. We got integral negative 7 to 4 of 1 minus x dx. I can assure you that they are wanting you to graph this thing and then find some kind of triangle that you're supposed to find the area of. That's fine. That's fine. I'm so happy for them. No. So, this here, what's the x power here is 0. And so then I'm going to add 1 to the power and divide by the new power. Here, with this x, isn't that a power of 1? So I'm going to add 1 to the power and divide by the new power. I'm going to go from negative 7 to 4. And so all these 1s here, is this really tacky? It's just basically a 4. And then minus 4 squared over 2. So there's my first thing. And then minus, and I'm going to plug in the negative 7. So I got a negative 7 and minus negative 7 squared over 2. That 2 doesn't look good enough. There we go. Blah, 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 calculator, 55 over 2. Cool. We only have 2 more problems left. Oh my goodness. It's going to be fantastic. 52059. I got integral 0 to 5 of f of x dx is equal to 31. Thank you. Thank you. That's exactly what I wanted. It's like, okay, well, now what? G of x. So integral of g of x dx is equal to 16. Yay! Thank you. And so then they say, what's the integral of 0 to 5 of 4f of x plus 6g of x? Yeah, okay. Don't stress this one, please. This is not one of those stressable kind of problems. The end. I mean, all you're doing is you're pulling the 4 out, splitting up the integrals and stuff. So, I mean, they're trying to teach you rules, I guess. They're trying to say, oh, did you know that if you had an x squared and an x, you could split this up as an x and an x squared separately. Wow, really? And so you got all these other cool properties, which I think that you're going to be learning through osmosis more so. If I could just give you a big old list and you'll forget it in 5 minutes. So as you go through, you'll be seeing more of these little rules, and that's nifty. So there you go. You could split up integrals, and that's what they're trying to say here, but it totally didn't come across that way. 52071. All right. This is just super exciting problem. They got m times b minus a is less than or equal to integral from a to b of f of x dx is less than or equal to capital M times b minus a. And just in case, little m is less than or equal to f of x is less than or equal to capital M. That's right. For no reason at all, we're reusing letters that make no sense. That's awesome. Does M mean slope? I don't know. Oh, I know what they mean now. I just wrote it down here. Minimum, maximum. That's what they're trying to say. Oh. Okay, sure. I'm so happy they stated this problem. And so then we got a pi over 16, and they got a pi over the 12, and they say 5 tangent of 4x dx. If you were just to integrate this generally, it wouldn't be terrible, but it is like going from like you're driving in your neighborhood or down just like a 30-mile-an-hour kind of street, and then they say, okay, well, now get on the highway. It's not the worst thing. It's just a little bit more advanced. So again, I'm not going to do that because that's actually going to be fruitless for us in this particular question because they have nowhere they actually care about this. They don't really want that. They want to find this minimum maximum stuff. It's not that hard, honestly. What they're really trying to say is that I'm going to plug in these values in for x directly, and then I'm supposed to multiply it by the distance that they had given us. And this is ending up, I'll show you, it's going to be a 5 tangent of 4 times pi over 16, and then times the interval itself, pi over 12 minus pi over 16. Now, there are a ton of pi's going on, and so what I would suggest is to remove these two and factor them out to the front. Make sure it's in radian mode, put it all into the calculator, and you actually should end up with a 5 pi over 48. And that is it. There's not much else to say there. There's actually going to be, what is this thing? This is m times b minus a. That's what this thing is. There's your B, there's your A, this is your M, and so now we got to find your capital M by plugging in the bigger number. Had to change my accent just for a second there, if you didn't notice. I got a 5 square root of 3 pi over 48, and yay, we did it! We got through this section. We're still in math prison for a little bit longer, but we're almost out of it. And then we could finally just be free of all this stuff and just do the math that we're supposed to do. Thank you very much. Have a great day.